Let's keep moving because I want to show you how this number line becomes really powerful for children. Later in the same second grade classroom, they do something called a number string. Some of you know what that is. You're in the room. Maybe I was in your classroom earlier today or earlier this week. This is part of our routine that we do at Math in the City. It's typically a mental math routine. So Aisha would bring all the children to the meeting area with those partners, and she would say, I'm going to put a statement up on the board, and I want you to think about if it's true or not true, and how you would convince all of us. You can imagine her saying that. So then she'd say, what about this one? 5 plus 20 plus 4 is the same as 4 plus 10 plus 15. And she'd wait, and they would think. And then she would say, when you think you know, take your thumb, just rest it on your lap like this, and that'll be a quiet symbol that you're ready to share your answer. And she'd look for some thumbs, and then she'd call on somebody. So I'm going to call on somebody. Is this true or not true? How do you know? Not hard for us. Somebody want to explain your thinking? It's true. Convince us. How do you know?
Because I count It's hard to explain.
Of course. Can someone translate? Say it in Swedish.
Nej, men alltså jag bara räknar ut på varsin sida.
And so what's on the left and what's on the right?
29.
So it's 29 on the left and 29 on the right. Okay, cool. Remind me of your name. Ali? Okay, so Ali says it's 29 on the left and 29 on the right, and I can make a picture of that. But I want to know, can you figure out that that's true even if you don't do that calculation? Because these problems are about to get harder. How could you verify that Ali is correct, but say nothing about the 29? Anybody have another way to convince us? I don't care about what's on the left and what's on the right. How do we know that that is equivalent, that that's a true statement? Can somebody else try a different way? Want to try it?
I counted how many tens I had, and I find 2 tens there, and I find 2 tens on the left. And then I count ones.
Okay.
And I get equal amount of ones and tens on each side. So I can see that I take away the ones, and I see 2 tens on one side and 2 tens on the other.
Do you see the 2 tens on this side?
Yeah,
I don't see it.
It's 2 on the 10 row.
You see this as 2 tens?
Yeah.
Okay, so in your mind you're actually thinking of this as a 10 and a 10, and where are the 2 tens here?
From 10, and then I take away 5 from 15, and I see 10 again.
Okay, so I think what you're saying is that there's a 10 here, and there's 2 tens here.
Yes.
And just so we keep track of it, I have to use the good marker. We only have 2 good markers. Just so we keep track of her thinking, she did this 10 and this 10, and this 10 and this 10. So now what?
And then I see 2 5s on each side because of that. Yes.
Okay, 2 5s.
And then 4 on each side.
And then a 4. And you think that if you have 2 10s and a 5 and a 4, and 2 10s and a 5 and a 4, it's equivalent. Notice that her strategy did not include the 29. So that's the difference. Your strategy, Ali, was about arithmetic. You used an arithmetic strategy. And Tillian used an algebraic strategy. And what we want to encourage is to be able to do both, but eventually to think algebraically. So next we do this. And we say, is this true? Here's our friend the foreign coin. And I don't know how big the foreign coin is, but could it still be true? And then we go here, and you might say, woo, I hate those. You should want to say, I don't feel like adding those up. I don't want to do what Ali did. But could I convince myself that this is true? Yes. And then we go here, where all of a sudden I'm putting coins together, and then I'm taking 6 away from the coin. What? And my last one is here. Will you choose one of these to make a model in your notebook to convince yourself if it's true or not true? And when I say model, I mean number lines. Choose one to make a quick sketch in your notebook. What would it look like?
Men blir det samma sak?
Och sen så får man det över en 36.
Den där ser ju samband mellan, men har de andra
Då är ju den
med dem?
Ja, det vet jag inte. Det har inte sett. Jag bara tog dem själva.
och då har vi inte riktigt någonting. Utan den bara håller på.
Men det är väl uppslag där du som har det
Himla bra. Så här kan vi skriva då att vi har tagit 5 och så har så blir det
Ja, ja.
och sen
Great. Love it. You see what's happening? Thinking of the model?
Yeah. Nej.
Eller ska vi ta en nya där?
Just det. Ja.
Okay. Here's another string. We'll just walk through it. We'll pretend that we're in 2nd grade. This one goes like this. And after a while you say, okay, so I don't have to talk about the 29. I can see a 25 on the other side. So I'll do this, and I'll take the 25 away, and then I'll have 4 and 4, and I know that's true. So what we're trying to do is encourage kids to think about equivalence and not to do computation. And then we do this. Ooh. But it's not that bad if you look and see how it's related. So in a number string, each problem is related to another problem. Right? And remember earlier I said I don't want children to think that each new problem they do in school is different. So I'm putting them together so they're just slightly different, but there's something that's saying the same. And then I go here, and I'm hoping you remember that 10, 10, and 5, and see the 13. And notice that now I'm talking about a 28, but then I take the 28 away. So it's like I do a jump, and then remember what Victor did? He then jumped backwards. So I jump 28, and then I come back. And then I do this, and maybe you can see the 10s inside of there, or maybe you know 10 and 18 is going to be the same as 15 and 13, and then so on and so forth. Okay, so that's called true or not true. That would be a routine that you would do with children, and you would do what I would do is you're the pen, you're making the pictures, kids are talking about their ideas. At the end of this unit, Aisha gives them this problem. She says, I have the same amount of money in both pockets. In her left pocket, she has 1 quarter, that's 25, 1 dime, that's 10, 1 nickel, that's 5, and a rare coin, a mystery coin. In the other pocket, she has 1 quarter and 6 nickels. Nickels are 5. And she says, in between my 2 pockets is the same. So can you figure out how much my rare coin is? And her children go right to the number line, and they find out how much is the rare coin. So this is an example of how she knows the kids are making sense. Okay, we're now going to do a frog jumping contest. So I'm going to ask you to find a new partner at your table for the next section, because now I'm jumping up to 4th grade or 5th grade. So maybe turn to the left, turn to the right, or switch seats at your table. Would you make a new partner? Okay. Let me tell you the story. This time I'm going to tell you the story as if you were in my class. In California, there's a frog jumping contest. I didn't bring the frogs with me, but I can tell you what it looks like. You're going to have to imagine it in your mind. It goes like this. In this county in California, people bring their prize-winning frogs, and they try to compete, and they try to win the contest. And what you'd see is a big kind of skinny track covered in dirt or sand, and it would be people watching over here and people watching over here, cheering on the frogs, go, 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 right? So all the spectators are here, and the contest starts, you put the frog on the ground, and you know what happens? They don't move. So here, and it's not because they're nervous, it's because they're frogs. So in order to move a frog, I've heard, you just tap it on the butt. Just give it a little tap, and then all of a sudden it goes. So the frogs do these big jumps until their legs get tired. You can imagine if you've done any long distance jumping or running, your legs get tired. And at the end, sometimes they do little steps with their legs. And then the referee comes and he measures from the beginning all the way to the end. And the measure he uses, he measures everything in the steps. Steps are the little jumps. Can you picture that in your head? So you're going to see frogs make these big jumps. So they're both high and they're long. Their legs get tired, and then they do a couple steps at the end. And what we say is that for each frog, their jumps are the same length. So what does that mean? It means that every time Cara jumps, we're going to just call that a Cara jump. It's this big, and this big, and this big. Why? Because my legs are not changing that much. But my jumps are different than Annette's jumps.
You're saying if 4 jumps and 8 steps lands here, then 2 jumps and 4 steps will be half of this?
Because then you have 2 jumps, 1 and 2 steps, and then you have half of this.
Okay, I would say you don't. I heard you say 4 jumps and 8 steps is 52.
Well, that was what I got when I knew this. Then I could go the back.
So that's what I asked you. If you didn't know that, could you still convince us it's 26? That's all we with that idea. So maybe 26 even
Men jag tänkte så här också. Och så hoppar den 2. Var det 2 nu? Och så gör man en hel. Så gör man som 1, 2, 3, 4. Så hamnar man
I spied on your notebooks. I heard people saying, Cara, everything cut in half. Everything got cut in half. So a lot of you said that to me. What do you mean? Everything got cut in half from the first situation to the second. Who can explain that? What do you mean? What got cut in half? Go for it.
The 4 jumps are cut in half, makes 2 jumps. The 8 steps cut in half makes 4 steps.
Okay, so finish that idea.
So it all together adds up. It's cut everything in half.
Cut everything in half. So I cut the number of jumps in half, the number of steps in half, and instead of 52, you say, I'll do 26. Yes? So where is the half in this picture? Is it easy to find?
No.
So how are we going to find it?
And you mix the jumps and the steps.
Okay.
You sort of
Rearrange.
Oh, rearrange. That's like Giovanni. That's okay? Let's rearrange. Let's rearrange this picture. How shall I rearrange it to find the middle? The middle ends up being really helpful. How should I rearrange?
2 jumps, 4 steps, 2 jumps, 4 steps.
You got it. So I'll do 2 jumps and 4 steps, and 2 jumps and 4 steps. And we said earlier back in 2nd grade, you can rearrange. That's still going to be 52. Now, can you see the half? Yeah, it's right there. Whew. And you're saying it's 26. Now, some people didn't use this strategy. You didn't rearrange. You did something like this. I saw you saying, oh, you have to know how big the jump is. And notice here, I haven't figured out how big the jump is. I just rearranged, and I looked at the relationships. Some people told me you have to know how big the jump is, and in order to do that, you go backwards. We know we can do that. And they said if you go back 8, you'll be at 44. And now you have 4 jumps, and they said, oh, those must each be 11. They did a lot of work. Then they took 2 of the 11s and put it together. They said 11, 11, 1, 2, 3, 4. Oh, that's 26. Raise your hand if you did it this way. You worked backwards. Okay. So that's what kids do too, but interestingly, kids often do this. And so notice the order of my question. My second question is, how big is a jump? My first question is, can you find this relationship between if I cut everything in half? Which is cool, and kids can do it without solving it. So to rename what just happened, some of you did this. This is called undoing. This is what you learned in school with algebra. When you add something, you subtract something. When you multiply, you divide. These are inverses. A lot of people instinctively do that. That's great, but you didn't have to. You could use proportions. You could just say the whole thing got cut in half, so I'll cut the picture in half. And lo and behold, it's at 26, and we can see from the picture that would make sense. Neat. Okay, let's think about what just happened. Some people say that when we make this picture, since we're talking about variables, this one, that really there's an equation there, and the equation is 4j plus 8s equals 52s. And I think, okay, sure. But then I see this, 4j plus 8 equals 52. And then it makes me wonder, what do we mean by s? And then I see this, and I think, is that okay? And then sometimes I see this. Will you talk to the people at your table? Are these all okay with you? Do they make sense to you? And are there any of them that trouble you? You're not comfortable with them, either as a mathematician or as a teacher. Talk to the people at your table. What do you think these all mean? Okay. I'll tell you a belief. If you work with Teachers College, you know that our job is not to lean over children and fix their writing. Oof, no, they're spelled wrong. Oof. We don't do that. It demeans the writer. Sorry, just an action. We also don't fix children's mathematics because it makes them feel as if they don't have knowledge or insight. So if I saw this on a child's page, I wouldn't come in and fix it. I would do what I'm doing with you. I would explore it and say, I walked around the room and I saw lots of people making an equation for this picture, and these feel different. So let's agree as a community about whether these are all true. So now I'm going to ask you, what do you think of these? Are there any of them that you say, yeah, that feels true to me and it matches the story and it matches the model and it's okay? Are there any here that you just don't like? They bother you. And tell us why they bother you. Who would like to start? You can do it in Swedish or English. Doesn't matter to me. Go for it.
I think number 1, 2, and 3 is fine. Good, just different thinking.
Okay.
The same result. But the fourth bothers me because since it was 52 steps and 8 steps, and it says 8 steps on number 4, but it doesn't say that the 52 is steps. So you can get confused and think that what is 52?
What is 52?
What is 52? And you have to ask for an extra explanation, which you can get, but it's not clear when you just read it.
What do you think? She said. You agree? 1 is okay, 2 is okay, 3 is okay, 4 is inconsistent, because we're talking about steps. And on these steps, we put an S, and on this, we don't put an S. So it's confusing. Yeah. Later in children's work, we'll get rid of the S. Because the truth is, the only thing in this problem that really varies is the J. The S is a unit. It's like a label. And sometimes we use variables as labels instead of quantities that vary. So eventually, I'm going to nudge kids to do number 2 or number 3, and we're not going to use an S at all. Because here in our problem, the S is not changing. It's staying the same. And by definition, a variable is a quantity that can change. So I'm not going to fix that now, but I just want to highlight that idea. Okay, you're going to need some paper for this one. Ready? Find some nice clear paper. We're going to take this contest a little trickier. And there's some nice, I forget what they're called, like little books in the middle of your table. This would be great.
Does anybody have extra?
Yeah, anybody have extra of those books? We have a couple here. I guarantee that everyone's going to be drawing and redrawing. If you are a perfectionist, You are not going to like this because you're going to want to get it right the first time. But that's part of the mathematics, is to just say, no worries, I'll just draw it again. Okay, let's have a contest. So, I got this frog. Guess what? His name is Frog. Okay, here he is. He jumps, whoop, 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 8 times. And the referee comes and he says, 96. Great, in a minute you're going to draw that. Jumping 8 times, and we measure it, and we're going to call it 96. Okay? Now, here's his competitor. Toad does it in the same time, starts at the same time, ends at the same time. And he also gets to 96. But each of his jumps is an 8. So he does a jump of 8, a jump of 8, a jump of 8, a jump of 8. I don't know how many. You'll figure that out. And he also lands at 96. You're going to draw a picture of that. Now, where this is going to get dicey is eventually, I want you to put the picture of Toad and the picture of Frog on the same number line. Because I want to know, do they ever meet up? Do their little feet land in the same place ever? And can you figure out why that would be? You got it? Okay, lots of drawing is about to happen. Off you go. You can work with your partner. Draw, redraw, crumple up the paper. No worries. Make a picture of this situation.
Så tänkte jag också. Men om man förstår Toddar så hoppar man 8 steg i taget.
Men den här är så han går i
Så han gör ju 12. Det här tycker jag är
So they make 2. And eventually, with lots of practice and some forgiveness, they're not so tough on themselves, they can get it to be 2. And notice there's some confusing parts about this diagram. Notice that this is Anne and Rachel, and in one, it looks like the jumps are 12, 12, 12, 12, 12, but look at the top. It says 12, 24, 36, 48. So they're keeping track of where the jump lands and how far the jump is in the same picture. And again, we're not going to fix this because there's lots of sense making. They're making sense of the situation. Notice also that one of the 96s is long and the other one is short. That's okay. We can work on that later. What they're saying is they can picture what will happen. Great. Okay, so that's Frog and Toad. What I would like to do now is a number string with you. And so I'd like to show you what this would sound like with children. And so this requires a little bit of rearranging the furniture. And then we'll come back and we'll do a little bit of tricky math from 5th and 6th grade to end the day. So what I'm going to suggest is that we turn off the screen. Maybe I can even do that. Woo, look at that. And I'll get some fresh paper. And what I'm going to invite people to do is bring their chair and something to write with. And I'm going to invite half of you to pretend that you're my students. You're going to do some math with me. And so I won't call on you unless you have your thumb up, so don't be nervous about that. And if you don't have your thumb up, I won't call on you. And the people on the outside, I'd like you to take notes about what do I do, what are my questions, and how am I making the math deeper, more interesting, okay? So you get to choose. In your partnership, I'd like you to turn to your partner and say, I'm going to be the mathematician, or I'm going to be the observer. And you have to agree. One of you is going to be in the string, the other one is going to observe. My partner, Jenny? Yep. Okay, anybody think they're supposed to be in the front and they're not here yet? Okie dokie. So, now what I'm going to do is tell you what a string is. Then I'm going to ignore all of you in the back. You're like my next class. I can't even see you. I can't even hear you. This is my class. So this is my class. I'm going to ignore you. Now, here's what a number string is. It's going to be a set of problems, just like those true and not true, right? And I'm going to be the pen, and I'm going to get all these mathematicians to think. And I'm going to start with a pretty friendly problem, not this one. And it's going to build and get a little trickier. If they're really trusting the string, they're going to see some nice relationships that they're going to trust, right? So that hopefully they're not going to do lots of calculation and say, oh, she's making us do more calculation, more calculation. No, that's not my goal. My other goal is to get them thinking in a model, and I'm going to choose a model that we've been working with today. So I'm going to try to name some strategies. I'm going to be the pen. They're going to do the thinking. You're never going to see how I would solve these problems. It's not important. Because look at all the mathematicians I have. I want their math on the poster, not mine. Okay? So that's what we're going to do. Now, you guys need a partner. So if these two are partners, Clara and Ali, and two, can you do dominoes? Find your partner. High five your partner. Woo! Now, on the outside, you need a talk partner too. Look around you. Look for someone new. Find a new partner. High five on the outside. Woo! Outside class. Ay, ay, ay. Everyone have a partner to talk to? Okay, now again, I'm going to build an invisible wall right here. Annette, I cannot see you. Lena, I cannot see you. Britt, I cannot see you. And I just locked us in, so now I'm with you. Here we go. You guys remember we were talking about the frogs, yeah? Okay, I want you to imagine a track that's 36. Just picture it in your head. Oh, by the way, you don't even need paper. Just imagine it in your mind, Ali. It's 36, and I'm going to put an animal, a jumping animal, on the track. And the jumping animal will go in 6s. But before we do that, why don't you pick your own animal? Can you think about an animal that you like that jumps? Tell your partner what your animal is. Go. Tell your partner what your animal is. Okay? Does everyone have their animal? Okay, what animals did you choose? Rabbit. Dog. Fox. Oh, jumping fox. Frog. Anyone have a crazy animal? We're going to give you a jumping elephant. Yeah, anyone have a tiny animal? Cricket? No? Okay, lock in your animals. Remember, we're trying to go to 36, so that's going to be what I'll call the track. That's like the distance. Your animal goes in 6s. My question is, how many jumps will that be? So I'll write that question. How many jumps will that be? And what will that look like? Okay, who can get us started? Who can get us started? And you're going to put a thumb like this if you can say, yeah, I can describe that. I got it. Don't be nervous. Who can get us started? Yeah. Well, go ahead, Marnie.
I go to 6, 12, 18, 24, 30.
Okay, I think you mean 6. Yeah? 12. Keep going.
Yes,
18.
18, 24,
Ooh, I'm going to run out of paper. Yep. 30. Oh my gosh, lucky. Great. Is this what you had in your mind? Great. How many jumps is this? Okay, so I'm going to do this. And I'm going to do that. Is that okay? Is that true? Great. Now let's take your animal, and now we're done with the training. So let's make the track 72. But remember, we jump in 6s. I know that you know the answer to this problem. So I'm going to ask you a different question. Can I use this model to solve this problem? And if so, what would it look like? Talk to your partner. Go. Okay. Come back in 3. Come back in 2. Come back in 1. Great. Who can help us with this drawing? Notice I'm not asking for the answer. Who can help us with the model? What will that look like? What will this look like? Go for it. Tell everybody.
Okay. Is the double of the track
this track is 36 and double is 72.
So Ali, are you saying that 2 of these will make this? Yes? I'm going to write what you said in symbols. 2 of those is the same as that. Is that true? I'm going to draw it and see if it works. Okay, so Ali said make 2. So I'm going to shrink it up a little bit. And we knew this was 1, 2, 3, 4, 5, 6. And you want another 6? Just like this? 1, 2, 3, 4. And he says that's going to be 72. Where's the answer to this problem in this model? What were we looking for? Ah, the jumps. Okay, so how many jumps is that? 12. Okay, so I guess we could say that we could do jumping in 6s to get to 72 will take us 12, or we could do 2 of those. Okay, now let's say your animal gets really strong. So now you can jump in 12s. Can I use anything here to quickly imagine what that looks like? Tell your partners. Can I use anything here? Go. Okay, what do we think? Can I use anything here to make this easy? Maybe I don't know my 12s. Let's get a new voice. Did anyone have a partner and your partner said something really smart, really helped you? Did anyone have a helpful partner? You want to talk about your partner? What do you think? I'm going to make a picture of this using something we've already done. Got it away? Yeah.
You can jump 2 6s.
Okay. Jump 2 6s like so. Whoop. And continue. What do you think will happen if I keep doing that? 2 6s is a 12, 2 6s is a 12. What will happen? How many 12s is that? 6. That's weird. Did you notice the 6 and the 12 traded places? Do you think that will always happen? I leave you with that question. Be thinking about if that's always going to happen. I'm not sure. Now, let's go to the Animal Olympics. Here we go. In the Olympics, this is like nothing. You would jump 144, and you've been training, so you're jumping in 24s. Ugh. So, this is a hard problem on its own. We have a story to think about. We have a model. Will you talk to your partner about how you're going to solve this problem with no paper and no pencil using the model? Talk to your partner. Go. Try to build the community. You saw what I just did there. I looked around and I said, whose ideas haven't we heard? And I went to Beata and Victor. And they're talking right now, and that's okay. Victor had a really cool idea. And instead of Victor, because we've heard from Victor today, we all know his name, I said to Beata, do you understand his idea? And she said, not yet, but now she does, right? Yeah. Here she goes. She's telling us Victor's idea. Go.
Victor said that 12 times 12 is 144.
Okay.
So then we said that 24 times 6 should be 100.
Okay, I'm going to make a picture of what you said. I think you said 12 12s will be 144?
Yeah.
Okay, now keep going. How does that help us?
We said that 6 24s should be 100.
Okay, are you seeing 24s in this picture?
Yes.
Help all of us to see the 24s.
2 12s is
Whoop.
24.
Okay.
And then you keep going.
Keep going.
You
Didn't we do this before? We put 2 together? Feels familiar, doesn't it? Weird. So we keep going, because I don't know my 24s. Do you know your 24s? Do you have your 24s in your head? No, me neither. Okay. What do you think? Yeah? So how many 24s will it take us? 6. Lovely. Okay. We have 3 more problems. How would you solve this problem? And really, what would it look like? Is there anything here that will help you with this? I went back to practice. We're not in the Olympics anymore. Which model would you use to solve this one? Which problem that we solved before? Mathilda, are you pointing to this? Yes? Yes, why? I think so too. Petra, you're saying just 1 more jump? Yeah, okay. You said before that 6 jumps, 1, 2, 3, 4, 5, 6, would be at 36. Can you say 1 more? And now we're at 42. Yeah? Okay, so what's the answer? 7. Okay, we know that one. Great. Now let's get a little fancy. Let's do a track of 126. And again, we're training. So let's jump in 18s. Ooh. I don't know about you, but I don't like these numbers. Let's think for 10 seconds. So let's really think. And now let's talk to our partners and see if you can figure out how to make this an easier, friendlier, simpler problem. Go. Talk to your partner. Okay. Whew. I don't like this one. Raise your hand if you don't like this problem. Yeah, a lot of us. Okay, let's make it friendlier. Mathematicians make a friendly version of the problem. What could help us make this friendly? If we don't want to take out paper and pencil. Victor could help us make it friendly. Okay, let's see if there's anyone else besides Victor who could help us make it friendly. Let's see if there's anyone else. Renee, you seem like you have an idea right here. Can you tell us? $42? Who? Okay. I'm going to pause you. You're saying if I do this picture 3 times, it'll be here. Is that true? 42, 42, 42, would that be 126? Okay, now, I don't have a lot of paper, so I'm going to make it really small. And I'll try to draw what you said to do. I think you said 1, 2, 3, 4, 5, 6, 7. Yeah? And then another time? Where am I now? 84. Okay. And then I'll do it again. 1, 2, 3, 4, 5, 6. Whew. And you say that's 126. Okay. What are these jumps? 6. And I can keep going. Okay. Do you think now you could take, is it Renee? Yeah, can you take Renee's idea? She said take 3 of them and help us to solve this problem, because we don't have 6s, we have 18s. What would you do? What's this? Okay, I'm going to pass you the pen, which I normally don't do, but I want you to have the satisfaction of making jumps of 18. Okay, watch what's going to happen. How many do you think they're going to be before you start? You're gonna do this?
My friend Jenny said come.
Yeah, Jenny, how many will there be? She's gonna do this. You think there's gonna be 7? Ooh, here we go. Let's count along with you. That was 1, 2, 3, 4, 5, 6. It's okay. 7. Nice job. Good team right here. So I guess this answer is 7? Great. Here's our last problem, and I'm not going to draw it, but can you picture what would happen if we were jumping in 9s? Tell your partner, quick. What do you think? If we were jumping in 9s, what could we do with this picture? What would happen? Okay. Did anyone have a nice partner who said, oh, that helped me to think about this one? Yeah, who had a nice partner? You had a nice partner again? Great. Victor, tell us about your partner. What did she say?
She said the jump's going to be half the...
Oh, yeah.
So we got 3 double
Okay.
jumps.
So the jumps are going to be half, so the number will be, I could cut this jump in half and this jump in half and this jump in half. And so how many will I have?
How many jumps?
Yeah.
14.
14. Oh, you're saying when the jumps get cut in half, the number doubles? That's interesting. Ooh. By the way, that's a big idea that we forget to teach kids. Now you might be saying, I don't know why this is algebra, Cara, this was division. So you should be thinking about, is this algebra? And am I getting you to think in a model? And could I have put a variable in here? I'm going to do that in a second. Will you debrief for one moment about, now we're done with the string? I wrote the problems in red. So you can see, they pop off the page. That was a string, it had 7 problems. Talk to your partner about how was that. If you're on the outside, what did you notice me doing that's different than what you do as a teacher? You get 1 minute to talk. Go. Okay. We have one little bit of math to do before we leave. You might be thinking, I'm not sure this is algebra. This feels like division. But notice how quickly I can say, let's jump 6 times and land at 54. And you could say, okay, yeah, I got it. And you could say 1, 2, 3, 4, 5, 6. Maybe you could even tell us what the middle is, because it looks like the middle. And maybe you could say those are 9s. And then I could say, okay, what if it's 3 jumps? And it lands at 54. And I bet you do this. You put 2 together, right? You'd say, whoop, 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 right? And then I could say something like, what if you jumped 6 times and you took 6 steps and you landed at 54? Now what? And then I could say, what if you jumped 3 times and you took 3 steps? Where would you land? So very quickly, when I establish this model and this idea of jumping, I can start to introduce this unknown jump, and we can figure it out using the model. This is an example of what I might do next with children. Okay, we have a little bit of math to do before we go, so let's put the tables back. Thank your partner. And so then I got home, and I didn't look at the price wasn't there, and it made me wonder, can you tell from that picture which costs more, a t-shirt or a hat? I'm not sure. So let's look at it for a second. I have 3 identical t-shirts and 4 identical hats, and it cost me $96. Can we tell which one costs more? If you think the hats cost more, say why. If you think the t-shirts cost more, say why. If you think you're not sure, tell your partner why. You get 1 minute to tell your partner. Go. Okay, let's take a vote. How many of you think that t-shirts are more? Raise your hand. T-shirts are definitely more. Oh, not so many. How many of you think the hats cost more? A couple of us. Okay, how many of you think there's no way to tell? Ooh, a lot of us. Why is there no way to tell? Why is this impossible? Some of you say. Why? Some of you are very clear. There's no way to tell, Cara, from that picture. Why not? Why not? Does someone want to try it?
We only know how much they cost together. If one's cheap, the other one is more expensive, or the other way. We don't know which one.
You're saying if I just gave you a picture of 3 t-shirts and I said 96, you would know, or 4 hats and 96? But I've got 2 things that you don't know, almost like 2 variables. That's what we're doing, friends. This is like 2 variables. So I'll go back to the store to make your life maybe easier, maybe not, and I'll do this. I went back to the store a different day and I got 2 shirts and 5 hats, and I thought it was going to be cheaper, and it wasn't. It was more expensive, and I was a little surprised. So my question is the same. Now can you tell which one costs more? And can you tell me how much more? Talk to your partner. Can you tell now? What do you think? Can someone say, now we can say for sure. How many of you think the t-shirts are more expensive? A couple people. How many of you think? No, do that again. You have to do it again.
No,
This is very Swedish, I have to say, and I don't mean to essentialize the whole culture. But as soon as you noticed you were the only one, you took your hand down. A minute ago you thought it was true, no?
That's when I realized I said that.
You changed your thinking?
I said the wrong thing.
Okay,
I
no
didn't
problem.
say what I was thinking.
You didn't say what you were thinking, fair enough.
I got it all wrong.
Fair enough, okay. I notice a lot of kids are scared to be wrong. It's true in America too, but I notice particularly Swedish kids don't want to be wrong publicly. I love a wrong answer. We talk about celebrating your beautiful mistake. That's what we do. Let me ask my question again. How many of you think the t-shirt is more expensive? How many of you think the hat is more expensive? How many of you can tell us how much more the hat is than the t-shirt? A couple people. Okay. Can you tell from these pictures how much a t-shirt costs? Or how much a hat costs? Or can you just say, yeah, those hats are a little more expensive? Not sure. Okay, here's what I'm going to invite you to do. I'm going to invite you to go back to this store that you've never been to and make up 2 more combinations that you think are true. Right? And a combination for us means some hats and some shirts. And then not only do you tell us how many you purchased, you're going to tell us the price. That's your job with your partner. Can you come up with a couple new combinations that might help us?
Vi säger att kepsarna kostar mer. Det blir så här. 4. Och då är det 4 kepsar.
Det är kepsarna där.
Anybody have a new combination? While you were working, I saw people doing something like this, making a chart, and I thought, that's nice. Could this be a way for us to organize these combinations? So I noticed that some of you are keeping track of how many shirts, how many hats, and the price. And I wonder, could we make up some new combinations? Does anyone have a new combination? You've never been to this store, but can you just say, yeah, that would be true? I think it would be true. Who's got a new combination? T-shirt? Okay. How do you know? You've never been to the store.
This happens when you leave. When you leave one t-shirt and take a hat, you gain $3 more.
Okay, tell us your name. Ava. So Ava's saying that when you do an exchange, the price goes up by 3, she's noticing. And she's thinking if you do that again, it'll go up by 3 again. Could that help us? Yeah, how? How could that help us? They're clapping for you at your table. How could that help us? That's cool. Would it help us to know 0 and 7? And how much would that be? 105. Do you remember when Åsa said, there's too many things changing in this problem? If there was only one thing, we could figure it out? Look what just happened. Now we just have one thing. Ah, pretty cool. So we could keep going. Does anyone have another combination? Like, would it make sense to maybe add a shirt and take away a hat? Could I do that? I'm going to add a shirt, take away a hat. What happens to the price? Yeah, it goes down. So I could keep going. And then I could solve this. Now, you did this problem in high school, probably, secondary school, and it's called the system of 2 linear equations. So I'll show you what it looks like when you saw it in high school. And it makes me really happy when I see 5th graders doing this problem. So probably when you saw it, and some of you actually wrote this, it was 3x plus 2y. Do you remember this? Yeah? And then you did 2x plus 5y is 99. And then maybe you put it on a graph, or you added them together, or you tried to you did a whole bunch of things that I'm guessing you had no idea what you were doing. So then I say, wouldn't it have been better to give you a story to make sense of it, and a model, where you were reasoning in the model? I have a feeling we did all this work with these symbols, and most of us didn't know what we were doing. For example, in high school, somebody told me you could do this. You could just add some stuff together. I don't know if you can do that. I don't even know what this is. It's a whole bunch of money. But then I think in this store, If I added the first picture to the second picture, would it make sense to add the two prices? Probably, right? Yeah. Okay, so I'm going to leave you with this idea, and I'm going to, there's a couple examples we didn't get to, but I can show you what we can do. I could go back to the store and buy sunglasses and shorts for $50, and you'd say, nope, I can't tell. And then I'd say, what if I do that? And you'd say, wow, now I really can't tell. But I'm going to encourage you to think in that table and see if you can make some new combinations. The other thing we do sometimes, we go to a fruit stand, and we just have apples and oranges, and then a different combination of apples and oranges. And then we do something really fun. We go to something called Sandwich World. Let me show you Sandwich World. In Sandwich World, there's only 3 things on the menu. You can only get a sandwich, an apple, and a milk, right? And so what's interesting about Sandwich World, you always get 2 things, and then the waiter brings the bill, which is great, except you want to know how much one thing is. So what we say to 5th graders, can you make up some new combinations for Sandwich World? And can you use your combinations, just like we did? Can you use your combinations to try to figure out the price of one? So Annette is going to send you this, eventually the video from today. You're going to have some materials, and then you're going to have these. And this might be, I'm going to give you some math to keep thinking about. Yeah? All right, now I'm going to pause. I'm going to talk about next steps. We're going to clean up the room, and we're going to go by 5 o'clock. You may be wondering, what should I do now? What after today? Our books, today I was borrowing from this unit, which you may want or you may not want, but if you wanted to learn more about Aisha's classroom, we did a bunch of problems from this book. It's intended for year 2. And then I moved over and I did some stuff from year 4 and year 5. This is called the California Frog Jumping Contest. If you opened it up, you'd say, oh, Frog and Toad, I know those guys. And both of them are supported by this book. Remember that guy, Bill Jacob, the guy who I said was an algebraist? That's him. So that's our newest book. That might help you or it might not help you. I started writing algebra books for high school, and that's my book. And then we started writing algebra work for teacher educators. That doesn't really help you because it's not in Swedish. Hooray! Our colleague, Cecilia, who works at Gothenburg University, took some of our work, there's Cecilia, and she translated it into Swedish. Finally, the work that I'm talking about is in your native language. This book is hot off the press, available. I'm not trying to make you buy a product. I'm saying that if today felt like, wow, I want to do this with my kids, this is the book that will help you to describe what it is that we are doing, and it'll help you describe to your colleagues, to your principal, how you're changing into a math workshop. So we have some flyers if you're interested in reading more about Math in the City in Swedish. Are those on the table, or do we want to pass those up? Down there. I got the chance to write an article in Swedish, and we have a whole bunch of copies of that. And this is the story of some New York City classrooms where I work. Again, lucky, it's in Swedish. It's on the back table. So that's exciting. And what else to tell you? We're going to skip the writing because it's almost time to go. But I'm going to give you this. And these are different ways that you can find us. If you like to tweet, that's good. Maybe you want to do some more number strings for year 1 students or preschool students. Or maybe you teach middle school. You can go here. That's where you can see what we're doing. And then that's where you can reach out and I can happily send you some more. Yep. Yep.